Next, we'll jump back to the composition called number 2, lighting options. Here we'll investigate some additional lighting options. So first, let's kill our spotlight by selecting it, then using backspace or delete to get rid of it. Then, from our source materials, choose 3D renders, and we're going to use the single takoyaki element and make him 3D. Once we add a light using our shortcut key, Ctrl-Alt-Shift and L, or using Command-Option-Shift-L on a Mac, we can create a new light. This time our light is going to be a spotlight. Our intensity will be 100 with the cone angle and the cone feather the same, but we'll modify this so that it casts shadows. When we click OK, we know that the light is casting shadows, but we're not seeing any shadows in our scene. The reason for this is that the layer itself has different properties which need to be turned on in order to cast shadows. By simply clicking and dragging the light over to the side, we see that the layer reacts to the light. We'll select the layer, then type AA on the keyboard to open up the material options for the layer. At the very top, we can see that Cast Shadows is turned off by default. By turning it on, this layer will now cast shadows from lights that create shadows. However, this layer is fairly dark. In order to modify this, we can change the rotation by typing R on the keyboard, then modify its orientation on the Y-axis so that it faces the light. The more it faces the light, the more light is reflected from those pixels and the brighter it becomes. However, if we move this away from the light again and type AA to open up its material options, we can see that one of the material options is not only to accept shadows, but to accept lights. If we turn accepts lights from on to off, After Effects is no longer going to use the lights in the scene to light this layer. Instead, After Effects will use the layer's color and opacity to define the luminance for this 3D layer. We'll turn Accept Lights back on, then twirl up the material properties for this layer, and move our light a little bit further from the center. In our source materials, let's check under the Movies in order to find the smoke animation. We'll bring the smoke animation into our layer. The smoke animation is a simple movie of fractal noise that just moves across the screen. We'll make this 3D, then with it 3D, we'll change its orientation by 90 degrees on the Y-axis. We'll move this layer over to the left so that it's more in front of the light. We can see a small circle on this layer where the light is contacting the layer. Next, with the smoke animation selected, we'll type AA on the keyboard to reveal the material options. Here we'll want to turn Cast Shadows to On. Now that we turn Cast Shadows on, the entire layer is obscuring the light from the rest of the scene. What's happening in our scene is that we're only seeing a shadow. Down below Cast Shadows is Light Transmission. We can change the way the pixels on this layer interact with the light by modifying its light transmission. With the light transmission value of 0, no light is going through this layer. But if we change the value to 100%, the light is going through the layer, not only showing the pixel animation of this layer as the light passes through it, but also any colors that exist on this layer. We'll select this layer and then switch it out with a movie called AB White Clouds 118. This is a clip of the sky provided by Artbeats. We'll simply select the layer, then holding the Alt or the Option key, drag down into the timeline to switch that layer out. Now, if we choose the takoyaki layer, then as we rotate him around his Y-axis, because we're using interactive OpenGL, the lights turn off for just a moment, then come back on once we're done, and we can see that the image of the clouds is projected with the light on all of the layers in our 3D scene. Not only is this layer responsible for the projection, but we can change the way this layer is presented by adding effects to it. So select the layer, then under Effects, we'll change its color by first adding a levels correction. We'll open up the panel so we can see the entire histogram, then simply crush the whites a little bit by dragging the input white value down below 255. Next, we'll add a different color correction, this time using Colorama. Again, under Colorama, there are several different output cycle presets, and we can simply choose Caribbean. We'll close this up, and now by looking in our comp window, we can see that the light is affected by this clouds layer that has been modified by the effects that we've applied to it. The only problem is that our octopus has changed color. We want to add another light into our scene in order to change the overall light for the entire 3D environment. We'll do this by adding an ambient light. So using Alt-Control-Shift and L, or Command-Option-Shift-L, we can add a new light, this time calling it ambient, and changing the light type to ambient. Now most times you're not going to want to use an ambient light that has an intensity value of 100%. This is going to blow out all of the shadows in your scene. Instead, we're only going to use our ambient light as a small fill for our scene. So we'll change the intensity value from 100 down to about 30. We'll also change the color value from white to a little bit more pink. Then click OK. Now we can see that we have a little more pink inside the shadows of our scene, but where the light is brightest, it's still blue, and because our octopus character was in shadow, bringing that pink ambient light has really brought up the reds in him. Now the way our shadows are rendered is described by a shadow map. And if we go up to our composition settings, underneath the Advanced tab, we'll see that we have the ability to add new rendering plugins or different options. And if we click on options, we'll see our shadow map resolution options. This is going to be how precise After Effects renders our shadows. Now, if you see a little softness or if you see some quickly moving pixels through your shadow, you may want to increase the shadow map resolution. You can do that here by changing it from our comp size to either a greater or a smaller value. Now, the greater the value of your shadow map resolution, the longer it's going to take to render. And if you change your shadow map from, say, 700 all the way up to 2000, the softness of your shadow falloff may change. So you may need to adjust all of those things if you modify your shadow map resolution after you set those up. So we'll simply dismiss this for now and hit cancel. But I wanted you to know that if you need to modify those, that's where you'll find them.